So we're going to talk about lesson 4.4 in our pre-calculus book a little bit more. We're going to talk about asymptotes, poles, and end behavior. First of all, a reminder about continuity that unlike polynomials, rational functions are not continuous. They have breaks in the graph where the denominator is equal to 0, and otherwise the graph is a smooth curve. Vertical asymptotes occur every place the denominator is equal to 0, but the numerator is not equal to 0. If both the denominator and numerator are equal to 0, then there could be a hole in the graph at that x value, except if the degree of the denominator is greater than the degree of the numerator. If that's true, then it's just a vertical asymptote. For end behavior, we look at when x is large. The polynomial function behaves like its highest degree term, as shown in section 4.3. For a rational function, the end behavior is determined by the ratio of the highest degree term of the numerator over the highest degree term of the denominator. And we're going to take a look at that. So we're going to identify the zeros, asymptotes, and poles of each function below, and then we're going to actually look at graphs of them. So I have three functions here, A, B, and C, and I have made a table to find the zeros, vertical asymptotes, horizontal asymptotes, and poles if there are any. So let's look at letter A first of all. First, it wants to find the zeros. And reminder, zeros are when the numerator is equal to 0. So if I set 5x plus 2 equal to 0, and we solve that, then we will get the x equals, so we subtract 2 and divide by 5, negative 2/5. So there's a 0 at negative 2/5 here. So the vertical asymptote then is when the denominator equals 0. So we have x plus 1 equals 0. So that would give us the line x equals negative 1. And so for vertical asymptotes, it's an actual line. Now horizontal asymptotes, to be able to find them, it's also, we're talking about end behavior here too. So if we talk about horizontal asymptotes, we're talking about what happens when the values of x are really, really large. So that's also the same as end behavior. So we'll write that here. Okay. Now, so we're going to look at just the largest degree term in the numerator and the largest degree term in the denominator. So in this case, that's going to be 5x over x. And when I simplify that, we're going to get number 5. So if it's a horizontal asymptote, or for end behavior, we're always going to write that as y equals. So this will be a line, a horizontal line, where y equals the number 5. And in this case, there are no holes, because there are no factors that are common in the numerator and denominator, or no zeros that are common in the numerator and denominator. So let's go ahead and let's graph this one first of all. So it says we have a hole, or a 0 at negative 2/5. So let's see, negative 2/5, that's about here. We'll mark that, about 0.4. And it tells us there's a vertical asymptote at x equals negative 1. So what we'll do there is we'll draw a vertical line at negative 1. Okay, and we're going to make it a dotted line too, because it's not really there. We're just showing the asymptote there. And then it says we also have an asymptote at y equals 5. So we'll draw a vertical asymptote, or a horizontal asymptote here at y equals 5. Right? And there are asymptotes. Now we're going to need to kind of make this graph a little bit from there, and we'll work from here. Right? So this graph is going to go, it's going to be up here, and second quadrant, oops. When you're drawing these, you want to make sure that they don't cross over the asymptotes. All right, so let's redraw that one a little bit more here. Let's try it again. So it's going to come from here, work its way up, and then go vertical. Put our arrows there. And then we can also look here to see where the y-intercept is, and the y-intercept is going to be at the point 2, because when x is 2, or x is 0, we get 2 over 1, which is 2. So we have a y-intercept at 2. And we know we have a 0 here at negative 2/5. So we're going to have this graph then. It's going to go here, through there, and up here. And then it will not cross the x-axis, that asymptote either. Okay. So there's for our first example, we have our zeros, vertical asymptote, horizontal asymptote, and the graph. Right? So let's look at letter B. All right, zeros, once again, when the numerator is equal to 0. So that's going to be when x equals 2 is going to be where we have a 0. Our vertical asymptotes, once again, that's when the denominator equals 0. So we're going to factor that first. We get x times x plus 6 equals 0. So we have the lines when x equals 0 and x equals negative 6. So we actually have two vertical asymptotes in that case. And for the horizontal asymptote, once again, we're going to put the highest degree term in the numerator over the highest degree term in the denominator. So that's going to reduce to to 1 over x, which if I put really large numbers in here for x, the bigger the number gets, the closer this gets to 0. So this is going to be the line y equals 0. And once again, there's no common factor here, so we don't have any holes in that graph. So we're none. Okay. All right, we're going to save that one and graph that one later. But we're gonna go ahead and look at letter C now. And we may come back and graph that one. We'll see. So to find the zeros, once again, in the numerator and denominator, one of the things you might want to look at, if they can be factored, you're going to want to factor the numerator and the denominator first. So let's go ahead and do the factoring here. So we get x minus 2 and x minus 3 in the numerator. And in the denominator, we get x minus 3 and x minus 1. Okay. So you can see that in this case, there is, let me write that a little bit better. In this case, we do have common factor of x minus 3 in both the numerator and denominator. And so that tells us there's going to be a hole at x equals 3. Okay. So that means then that there's only a 0 at positive 2 where the numerator is 0. And for vertical asymptotes, there's only going to be one of them, and that's when x equals 1. So because there's a common factor here, that means there's a hole in the graph. That means it's not a 0 or a vertical asymptote. And then when we find our horizontal asymptote, or end behavior, put x squared over x squared, which is simply 1, so we'd have y equals 1. So here then we have what would be our horizontal asymptote. So if we graph this one, all right, so we have a 0 at 2, and we have a vertical asymptote at x equals 1, so we'll draw that line. And the horizontal asymptote at 1. And then what we're going to do is that there's a hole here at x equals 3. So if I put 3 in for x to find exactly where that hole is, right, so if we put 3 in here for x, we'll get 3 minus 2 over 3 minus 1. Okay, we're ignoring these two, the common factor. And that would give us 1 over 2. So there's a hole at the point 3 and then 1/2. So I'm going to have a hole right here. So I'll actually put a hole in my graph. So this, when I go ahead and draw this graph then, it's going to go here. Let's see, it's going to go up here and over. And then it's going to leave that hole and then it'll continue on. And then the other side here, let's see, we got our y-intercept. Would be at 2, 6 over 3. All right, so then we draw the graph over here. Not very good at drawing these graphs, but we have the graph here and there. And there we go. There's our look at zeros, vertical and horizontal asymptotes, and holes in our graph.